And banana guys. Okay, the parabola. Right, now we all know that the parabola takes on the equation ax squared plus bx plus c. They can say y is zx squared plus dx plus q. All right, they can give you any flippant formula, any variables in the place of a, b, and c. But as long as there's a x squared, a x, and a constant, your brain should register that this is a quadratic, a parabola. They can also say the quadratic equation. They can also say it's a parabola. Yeah, whatever word they use for the graph, you just have to identify and make sense with the equation for you to figure out what's happening there. Now, in the equation, c or the q value, let's just write q value will then become our y-intercept. Now, if you can imagine this, y-intercept is where x is equal to 0. Okay? So if I put a0 squared plus b0 squared plus c, 0 squared is 0. So a times 0 is 0. b times 0 is 0. I'll be only left with c. That's why we say that c is the y-intercept of the graph. Okay. Now, we come to this value here, the a value. They will never ask you that much theory on the a value, but what you should recognize is if the graph is in that form, we can see that a is greater than 0, right? And if a is greater than 0, it's positive. It is positive. And now, like I said, if I am positive, then I'm greater than 0. And if you're positive, you're in a happy mood, you're smiling. So I will then take on a smiling parabola. Now, please note, when the parabola is smiling, then we say it has a minimum value, and that will be your y value. So the y value is a minimum. They will normally ask in a question, what is the minimum value of the graph? All right. If you go into pre-optimization before grade 12, where they give you two graphs and they want the length, minimum length, something like that, you will realize that that graph will have a minimum y value. That graph would be positive, right? We'll explain that when we go to questions that involve pre-optimization, right? It has a minimum value when the graph is positive, right? When we say that a is less than 0, it will take on the equation y is equal to negative ax squared plus bx plus c, right? And then we say that the graph is negative. Now, if you're in a negative mood, you are sad. Look at it. It's so sad, eh? You are sad, so your graph is frowning. And if your graph is frowning, it has a maximum value. Right. For now, we'll deal with this equation, but there's 3 equations that we need to learn, but we'll do that when we discuss the equation. Okay. When we speak about the domain and range of the graph, the domain, unless stated otherwise, and I'll try and look for examples where it is unless stated otherwise, is x is an element of R. What does domain mean? If I were to plot the graph, this graph here, let's just plot the graph here. Okay, whether the graph is sad or smiling. Let's plot a smiling graph. Let's plot a smiling graph. We'll just plot a graph there. Forgive my shape. That arrow there and that arrow there is not just there for pomp and pageantry. That arrow there, if you remember grade 7 or grade 9 maths, it means that the graph is continuous. This graph will keep on going, 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 keep on going. It will keep on going, keep on going, keep on going. And domain is how far the graph goes right and how far the graph goes left. That is domain. Now, if this graph keeps on going, it keeps on going, it keeps on going, it keeps on going. Can you guys agree with me that if you go right, X numbers become positive. So this graph will keep on going until we do not know, until positive infinity. And if it keeps on going to the left, it keeps on going, keeps on going, keeps on going. Then, please don't mind my nails, then we say as we go left, X becomes negative. But we don't know where does this graph stop. Then we say the graph goes up until negative infinity. That is why we say it is an element of real numbers. That's what negative infinity to positive infinity means. Now, if you love writing and you love being fancy like Joko and you love writing your domain and range in set builder notation, then you will just say that X is an element. But now, we are not certain what infinity is. So it's going to gain a round bracket. Negative infinity up until positive infinity. Okay. Now we come to matters of range. Now, if your graph, let's just write range for a greater than 0. If your graph is smiling, we say it's greater than 0, nay? Your range will then be y is a element of. Remember we said if the graph is smiling, it has a minimum value which is going to be the turning point, the y coordinate for the turning point. So it will then be the y coordinate for the turning point up until positive infinity, because now you look, okay, the graph has a minimum there, y value for the turning point. But now, like I said, what does that mean? This line just continues, right? So which means this line, this graph actually, is going to keep on going on top, 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 until flippin' God comes. That's why we say positive infinity. Now, for a is less than 0, the graph becomes like that. Now, range and domain is always from smallest to biggest. This graph, we can see, keeps on going down, but we don't know where it's going to stop. It just keeps on going down forever and forever and forever. Amen. Right? That means it will have round bracket negative infinity up until it has a maximum value. So ranges from minimum up until maximum. It has a maximum value, certain maximum value. I made a mistake that I'm going to fix now. Because we know the certain maximum value, because it's a y coordinate for the turning point, because we can get the turning point, and we know that it stops there, we're going to give it a square bracket. Same for here, it's supposed to be a square bracket. So sorry. A square bracket because we know that minimum value, because we can calculate it using the bim bada boom bada bim bada boom boom bim bada boom, because we can use a calculator in the turning point formula. I hope you understand. After this next video, I'll be just doing a sum, and then we'll go to finding the equation.